All right, today we're going to go through the bell work first, jump into some new content regarding radical expressions. First one, square root of 125. Some of you guys may have simplified this in a different way, but this is how I kind of made sense of it. 125 has a factor of 25 to it, so I'm going to write this out as the square root of 5 times the square root of 25. Square root of 25 is 5, so this would just simplify to 5 times the square root of 5 times the square root of 5. The second one, square root of 243x to the 5th power. When we look at 243, that's another number that's, I believe, has a perfect square factor inside of it. And I think that 81 works for it. So I'm going to do the square root of 81 times whatever gets us 243, which I believe is the square root of 3. That x to the 5th power, we can break that up into the square root of x to the 4th times the square root of x, and then we just put it all together. Square root of 81 is 9. The square root of x to the 4th power is x squared. And then we've got that square root of 3 and the square root of x that are going to remain underneath the radical symbol. So you should have 9x squared times the square root of 3x. As we scroll down and take a look at the last one in the bell work, 3 times the square root of 12z to the 2nd times 5 times the square root of 4z. Again, many ways that we can do this. I always like to start with my 3 and my 5 and multiply those together first to get 15. The square root of 12 and the square root of 4 both share a common factor, or we could just simplify it by multiplying the two numbers together. We could write that as the square root of 48 if we wanted to. However, if you can notice that 12 has a factor of 4, we could write that out as square root of 4 times the square root of 3 times the square root of z to the 2nd power times the square root of 4 as well times the square root of z, and then simplify it that way. Square root of 4 and the square root of 4 just makes 15 times 4. Square root of z to the 2nd power is just z. So we've taken care of, let's see here, take care of this, take care of this, take care of this. The only thing left then is the square root of 3z. So we would just write that at the end, square root of 3z. Okay. Completely simplified, 15 times 4, that gets us, I believe, 60z times the square root of 3z. Okay. So today we're going to work on something new. And getting into and remaining with our radical unit, we're going to continue working with properties of square roots. So you guys can take out your notes at this time, write down any examples that you can. Apologize you can't be there today, but hopefully this video will be helpful. The vocab of the day starts us with our division property of square roots. Basically saying if you take the square root of a fraction, you can kind of break up that square root into two different square roots with the numerator and the denominator also containing their square roots. The example is given here, the square root of 36 over 49. This one's a relatively easy one because 36 and 49 are both perfect squares. You guys will notice today that that's not always the case. This simplifies to square root of 36 over square root of 49, which we can simplify to 6 over 7. Okay, so essentially what we're doing here is when you take a square root of a fraction, you can break the square roots up into two separate radical expressions. Now, this is something to be aware of. When the radicand in a denominator is not a perfect square, remember our perfect square numbers are like 4 and 9 and 16, 81, those types of numbers. You may need to do what's called rationalizing the denominator. Okay? If you remember back to our rules, one of the rules when we simplify expressions like this is that we must not contain any radical symbols in the denominator of a fraction. Okay? So to do this, we're going to multiply the numerator and denominator by the same radical expression. We'll show you a little bit more of what we mean by this with a couple examples here in a second, but just know that that is something that we will be asking you guys to do in terms of simplifying these types of expressions. So let's just jump into some examples and talk about how to simplify them. First ones should be relatively easy. Square root of 64 49ths. Now one method that you guys can take is by simplifying 64 49ths first. However, right now, since both of those are perfect squares, this is relatively easy. This is square root of 64 over the square root of 49, which is going to simplify to 8 over 7. Okay, relatively easy on that one. Second one, 8x to the third over 50x is one of those examples of one where we may need to simplify the expression inside first. If you look at 8 and 50, we're not going to completely, or I'm not going to completely simplify this. However, if I divide 8 by 2 and 50 by 2, I get the square root of 4 over 25, which you guys can notice that both of those are square numbers, okay? Also, if you look at your x's, you got x to the third over x. We've learned in our exponents rule that if you have x to the third power on top and x on bottom, that this simplifies to just x squared, okay? So in essence now, what we have is the square root of 4x to the second power, which we can simplify relatively easily, over the square root of 25, which also is simplified pretty easily. Our answer for this one would be square root of 4, which is 2, square root of x to the second, which is x, over square root of 25, which is 5. We've got 2x over 5. The last example here, relatively easily, you guys can try this one on your own or think about what the answer would be. We would split this up into square root of 12. Oops, excuse me, jumping the gun there. This would just simplify to 12 over 3, which also simplifies to the number 4. Okay? Let's test out some other examples. You guys can pause the videos as you go if you'd like. Square root of 36a over 4a. And again, if you notice, we've got the 36, which is a perfect square, the 4, that's a perfect square. We could break this up if we'd like. Square root of 36 over the square root of 4. Now, what I like to do is especially with a's over a to the third, is just simplify this expression. If you remember, this is a to the first power over a to the third power, which would leave one of those a's canceling off and leaving a to the second power in the basement. And we still do need to take the square roots of that a to the second power. So that's just a little quick trick that you guys can do to kind of save yourself some time. Square root of 36 is on top. That's just going to be 6. Square root of 4 is 2. And then the square root of a to the second power is just a. So our final simplified expression, whoa, what do you guys see with this? 6 over 2a. What can we do with that? Hopefully you guys are saying simplify, because 6 is divisible by 2, so we would actually simplify this to 3 over a. Another example here of a problem that can be simplified using these methods. Now, in this case, we've got y's and z's, so our exponent rules are kind of out the window since the bases are different. However, we can still break this up. This is square root of 25 on top times the square root of y to the third power, which if you remember, you drop the exponent 1 and write it as y to the second times the square root of y, all over the square roots of z to the second power. And when we simplify that expression, square root of 25 is 5. Square root of y to the second power is just y. Square root of y is going to stay the square root of y. Notice it's not in the denominator of the fraction, so we can leave it upstairs. And then the square root of z to the second power is just z. So this would simplify to 5y square root of y over z. Now, what we're going to do next is referred to as rationalizing a denominator. In this situation, we've got a radical symbol in the denominator of our fraction. Okay, but we can take care of that relatively easily, right? If you remember from anything regarding fractions, if you multiply the fraction by 1, it doesn't change the fraction. And there are many different forms of the number 1. So in this case, we've got the square root of 7 on bottom. What we want to do is try and cancel out the square root. And the only way to cancel out a square root is by multiplying it by another square root, which I'm going to choose as 7. Now, if we're multiplying a fraction by 1 and our efforts are not to change the fraction, we should put the square root of 7 on top as well. Again, this is called rationalizing a denominator. Now, when we do this, we get square root of 3 times square root of 7, which is square root of 21, over square root of 7 times the square root of 7, which is just the number 7. Now, I don't believe square root of 21 has a perfect square factor in it, so in this case, we would just leave it as square root of 21 over 7, and that would be our answer. All right, let's take a look at some other examples. In this case, we had square root of 8n in the basement. So again, our process is to multiply by the square root of 8n on top and bottom. Square root of 8n over the square root of 8n. What that's going to get us is square root of, let's see, 7 times 8, which is 56. Over n, and over the square root of 8 times the square root of 8, which is just going to be 8n. Okay. Now the square root of 56, we need to think to ourselves, does that have any perfect squares? Can we simplify that expression? My guess is that it is. It's even, although it's not divisible by 4. I do not believe it's divisible by 3. Let's see here. We could break that up. We can check. Square root of 56 could be like square root of 8 times the square root of 7. Square root of 8 has got a perfect square factor of 4 and 2. So this is square root of 4, square root of 2 times the square root of 7. And that would, again, simplify just to 2 times the square root of 14. And we still have our n in there, so this would actually come down to 2 square roots of 14n over 8n. And again, we need to look for fractions to simplify. 2 over 8 simplifies to 1 over 4, so we're just left with, when this reduces to 1 and this reduces to 4, we're just left with essentially square root of 14n on top over 4n on bottom. Square root of 2 over square root of 3. Again, the rationalization portion of this just has us multiply by the square root of 3 on top and bottom. And that gets us square root of 6 over the number 3. Square root of 6 does not have any perfect square factors, so we're good to go. That's our answer. All right. Take a peek at your homework for tonight. It's written on the board. And try this out, get your hands dirty with it. Again, these expressions are not easy by any means, but we need to practice them and sort of experience some failure once in a while with them and learn from them before we get good.